You've watched your power bill climb month after month, but you can't figure out what's actually burning through all that electricity. Real-time energy monitoring changes that completely. It shows you exactly which devices are draining watts right this second. And homeowners who install these systems typically cut their monthly bills by 10 to 15% within 6 months. I'm Marcus Chen, and I've spent years helping people understand how these systems actually work. You're listening to the Smart Home Setup Podcast. Quick note before we jump in, the research, data, and everything you're about to hear has been written and verified by real people who actually know this stuff. But the voice you're hearing is AI generated, which lets us get these episodes to you faster and more consistently. If you've been listening for a while, seriously, thank you. It's great to have you back. And if this is your first episode, welcome to the show. We release new episodes every Monday, Wednesday, and Friday, and each one digs into a specific aspect of smart home tech that actually matters. Today we're talking about real-time energy monitoring, what it is, how it works, and why it's one of the best investments you can make if you're serious about cutting your power bill. Let's get into it. Real-time energy monitoring tracks your home's electricity consumption second by second and displays that data through a smartphone app, web dashboard, or integration with your smart home hub. Unlike your utility meter that gives you monthly totals after the damage is done, these systems show you live wattage readings for individual circuits or devices. When people ask about real-time energy monitoring in smart homes, they're usually talking about one of two setups: whole home monitors that install at your electrical panel and track every circuit, or plug-level monitors, basically smart plugs with energy tracking that measure individual devices. Whole home systems use current transformers, called CTs for short. These are clamp sensors that wrap around your panel's main feeds or individual breakers. They detect magnetic fields generated by current flow and convert them into power readings. The data transmits via Wi-Fi in most residential systems, though some commercial-grade equipment uses Ethernet. Plug-level monitors integrate energy tracking into smart plugs using built-in current sensors. These typically communicate via Wi-Fi, Zigbee, or Matter, depending on the manufacturer. Check the link below to see the current price on a common Wi-Fi example, the TP-Link Casa Smart Plug Ultra Mini, which tracks consumption for whatever device you plug into it. Here's what matters when you're choosing protocols. Wi-Fi monitors connect directly to your router with no hub required, but they increase network congestion. Zigbee monitors require a compatible hub like SmartThings, Hubitat, or Home Assistant with a Zigbee coordinator, but they use less bandwidth. Matter monitors promise cross-platform compatibility, but they're still emerging for energy monitoring applications here in 2026. Z-Wave monitors exist, but they're rare for energy tracking. Most manufacturers abandoned Z-Wave for this category. I've seen homeowners struggle when they buy a Zigbee smart plug with energy monitoring, but don't have a hub that exposes energy data through its API. The plug works fine for on-off control, but the consumption readings stay locked inside the hub's proprietary app, where you can't do anything useful with them. Now, let's talk about how these systems actually work. The technical mechanism depends on whether you're using current-based monitoring with CTs at the panel or voltage drop monitoring with smart plugs. For whole home panel monitors like the Emporia View Gen 2, which you can check the link below for pricing, you'll need to mount the main device inside your electrical panel. That requires turning off the main breaker, so hire an electrician if you're not comfortable working in there. You'll clamp CT sensors around your main power feeds, typically two 120-volt legs for split-phase 240-volt service in North America. You can optionally clamp individual CTs on specific breakers you want to monitor separately, then connect the monitor to Wi-Fi and configure everything through the manufacturer's app. Here's how the sampling mechanism works. CT sensors sample current 4,000 to 8,000 times per second, depending on the model. The device multiplies current by voltage, assumed at 120 or 240 volts based on the circuit, to calculate instantaneous wattage. It updates your app every 1 to 2 seconds. As far as accuracy expectations go, quality CT monitors achieve 95 to 98% accuracy for resistive loads like heaters and incandescent bulbs.
Accuracy drops to 85 to 90% for reactive loads, motors, power supplies with capacitors, because they introduce phase shift between current and voltage. You'll see this with HVAC systems and appliances with compressors. Communication latency matters too. Wi-Fi monitors typically push data to the cloud, which introduces 2 to 5 second delays. That's acceptable for energy tracking, but too slow for real-time load balancing automations. Local-only systems using Home Assistant or Hubbitat with MQTT integration can achieve sub-second updates. Moving on to smart plug energy monitors. These use a shunt resistor or Hall effect sensor inside the plug to measure current passing through the device. The automation logic looks something like this. If the plug's current draw is greater than 5 watts for 60 seconds, mark the device as on and log power consumption. Otherwise, mark the device as standby. Protocol differences really matter here. Wi-Fi plugs like Casa or Wemo update every 1 to 2 seconds. They're cloud-dependent and they work with Alexa and Google, but not locally. Zigbee plugs from brands like Sangled or Third Reality update every 5 to 10 seconds via your hub. They work locally if your hub supports it, and they have better mesh reliability than Wi-Fi. Matter plugs are emerging in 2026 and should update every 2 to 3 seconds locally via Thread with cross-platform compatibility. Here's a real-world automation example using a Zigbee plug with Home Assistant. If the washing machine plug's power is greater than 10 watts, set the washer status to running. If the washing machine plug's power is less than 5 watts for 3 minutes and the washer status equals running, send a notification that laundry is done and set washer status to idle.
This logic relies on consistent, frequent updates. I've seen automations fail when Wi-Fi plugs lose connection and stop reporting. Your washing machine finishes, but you don't get notified until the plug reconnects 10 minutes later. Here's the fallback behavior you need to know about. Most Wi-Fi energy monitors continue tracking locally when internet drops, but don't push data until reconnection. Zigbee and Thread monitors maintain local operation if your hub doesn't depend on cloud services. Check this explicitly. Some manufacturers, and I'm looking at you, Tuya-based devices, brick entirely without internet. For a deeper comparison of monitoring devices, we've got a guide comparing Sense versus Emporia View energy monitors linked below. So why does real-time energy monitoring actually matter? You can't manage what you can't measure. The practical value comes from 3 main capabilities. First, identifying phantom loads and energy vampires. Devices in standby mode, TVs, cable boxes, coffee makers with digital displays, consume 5 to 20 watts continuously. That's 120 to 480 kilowatt hours per year per device, or $15 to $60 in wasted electricity at typical residential rates. Real-time monitoring exposes these hidden drains immediately. You'll see which devices are pulling power even when they're quote-unquote off. I've helped homeowners discover that their desktop computer in sleep mode consumed more electricity annually than their refrigerator. Second capability is enabling time-of-use rate optimization. If you're on a time-of-use utility plan, electricity costs 2 to 3 times more during peak hours, typically 4 to 9 p.m. Energy monitoring enables automations like this. If the time equals 3:55 p.m. and the utility rate is transitioning to peak, then turn off the EV charger, pool pump, and dishwasher. This requires integration with your smart home hub and energy-saving automations that respond to rate schedules. Matter and Zigbee devices with local control excel here. Wi-Fi cloud devices introduce lag that can miss the rate transition window. Third capability is detecting device failures before they escalate. Abnormal power consumption patterns signal problems. If your refrigerator is drawing 50% more power than baseline, you're likely looking at a failing compressor or dirty condenser coils. HVAC systems short cycling with frequent on-off spikes? That's thermostat misconfiguration or low refrigerant. Sump pump running continuously? Check valve failure or stuck float switch. In my experience, homeowners who catch these issues early save $500 to $2,000 in emergency repairs versus waiting until the appliance dies completely. We've got a smart home energy audit checklist linked below that walks through systematic detection of these issues. Not all monitoring approaches suit every home, so let me break down the types of real-time energy monitoring systems. First, CT-based panel monitors for whole home tracking. These are best for detailed circuit-level tracking, larger homes over 2,000 square feet, and identifying which circuits consume the most power. Examples include the Sense Energy Monitor, Emporia View, and AOTech Home Energy Meter, which uses Z-Wave. Check the links below for current pricing on these. Protocol-wise, these are almost exclusively Wi-Fi with cloud dashboards. The AOTech model uses Z-Wave but requires a compatible hub like SmartThings, Hubitat, or Home Assistant with a Z-Wave stick. Installation barrier is real here. You need electrical panel access, which means you'll need a licensed electrician in most jurisdictions. Budget $200 to $400 for professional installation on top of the hardware cost. Accuracy is 95 to 98% for total home consumption, 85 to 90% for individual circuits, especially ones with mixed loads, like a kitchen circuit powering both resistive and reactive devices. The limitation is that most can't identify specific devices automatically. They just show you that circuit 5 is using 1200 watts. Device disaggregation, figuring out what's actually running, requires machine learning models that need 2 to 4 weeks of training data. Second type is smart plugs with energy monitoring for device-level tracking. These are best for tracking specific high-consumption devices like space heaters, window AC units, entertainment centers. They're also perfect for renters who can't modify electrical panels. Examples include TP-Link Casa plugs on Wi-Fi, Senglid Smart Plug on Zigbee, and Third Reality Matter plug on Thread and Matter. Protocol choice depends on your existing ecosystem. Wi-Fi works standalone but requires strong router signal. Zigbee requires a compatible hub. Matter plugs need a Thread border router like an Apple HomePod Mini or Google Nest Hub Max. Accuracy runs 90 to 95% for devices with consistent loads. Accuracy suffers with variable speed equipment. The limitation here is obvious. You can only monitor what you plug in. It's not practical for hardwired appliances like HVAC, water heaters, or ovens. We've got a guide on the best smart plugs for energy monitoring linked below with protocol-specific recommendations. Third type is hybrid systems, combining a panel monitor with individual CTs. These are best for homeowners who want a whole home overview plus granular tracking of 4 to 8 specific circuits. The Emporia View supports up to 16 individual CTs. You install the base unit at the panel and add CTs for circuits you care about, like HVAC, water heater, EV charger, dryer.
The trade-off is cost. You're looking at $200 to $350 depending on CT count, but it provides the detail level most homeowners actually need. I rarely see people use more than 8 individual CTs. Beyond that, the data becomes overwhelming rather than actionable. We've got a smart home energy management system setup checklist linked below for deeper guidance on system selection. Let me address some frequently asked questions. How accurate is real-time energy monitoring in smart homes? Real-time energy monitoring achieves 90 to 98% accuracy depending on the load type and monitoring method. CT-based whole home monitors reach 95 to 98% accuracy for resistive loads like heaters and lights, but drop to 85 to 90% for reactive loads like motors and power supplies with capacitors due to phase shift between current and voltage. Smart plug monitors with shunt resistors typically achieve 90 to 95% accuracy, but can drift over time as the resistor ages. Expect 2 to 3% degradation after 3 to 5 years of continuous use. What smart home protocols support energy monitoring devices? Wi-Fi, Zigbee, Z-Wave, and Matter all support energy monitoring, but Wi-Fi dominates the market in 2026. Wi-Fi monitors connect directly to your router without requiring a hub, which explains their popularity.
Zigbee energy monitors need a compatible hub like SmartThings, Habitat, or Home Assistant, and typically update every 5 to 10 seconds versus 1 to 2 seconds for Wi-Fi. Matter support for energy monitoring launched in the Matter 1.3 specification, so thread-based Matter plugs with energy tracking are finally appearing in 2026. Z-Wave energy monitors exist, but remain rare. Most manufacturers abandoned the protocol for this category. Can I use energy monitoring with Alexa and Google Home? Yes, but functionality varies by protocol and device manufacturer. Wi-Fi energy monitors like Casa, Sense, and Emporia integrate directly with Alexa and Google Home voice assistants, letting you ask things like, "Alexa, how much energy is my house using?" Zigbee energy monitors require their hub to expose data through Alexa or Google Home skills, and not all of them do. Matter energy monitors should work universally across platforms, but voice query support for energy data is still inconsistent across assistants in early 2026. You'll get better automation capabilities using Home Assistant or Habitat rather than relying on voice platforms.
How fast does real-time energy monitoring update consumption data? Update intervals range from 1 to 10 seconds, depending on protocol and architecture. Wi-Fi whole home monitors update every 1 to 2 seconds locally, but display data with 3 to 5 second cloud delays. Zigbee smart plugs typically update every 5 to 10 seconds through your hub. Thread and Matter plugs should update every 2 to 3 seconds locally without cloud dependency. For load balancing automations or time-of-use rate optimization, you need sub-2 second updates with local processing. Cloud-dependent Wi-Fi monitors introduce too much latency. I've seen automations miss peak rate transitions by 30 to 60 seconds because of cloud round-trip delays. Do energy monitors work during internet or hub outages? Local operation during outages depends entirely on device architecture and protocol choice. Most Wi-Fi energy monitors continue measuring and logging data locally when internet drops, syncing to the cloud once reconnected, but you lose real-time dashboard access. Some cheaper Wi-Fi models, especially Tuya-based devices, stop functioning entirely without internet. Zigbee and Z-Wave monitors maintain operation if your hub runs locally, like Home Assistant or Habitat, but fail if your hub depends on cloud services like SmartThings. Thread and Matter monitors should operate locally via border routers, but fallback behavior varies by manufacturer. Test this explicitly before committing to a system. Real-time energy monitoring puts you in control. What real-time energy monitoring smart home systems deliver is visibility, and visibility creates behavior change. You'll shut off devices you didn't realize were drawing power. You'll shift high-consumption tasks to off-peak hours. You'll catch appliance failures before they become emergencies. The protocol choice matters as much as the monitoring method. Wi-Fi works for most plug-and-play setups, but locks you into cloud dependency. Zigbee offers local control and mesh reliability if you already run a compatible hub. Matter promises future-proof cross-platform compatibility, but the energy monitoring ecosystem is still maturing in 2026. Start with a whole-home CT monitor if you want comprehensive visibility, or deploy strategic smart plug monitors if you just need to track a few power-hungry devices. Either approach pays for itself within 12 to 18 months through reduced consumption and avoided equipment failures. Your utility bill won't explain itself, but real-time energy monitoring will. That wraps up this episode of the Smart Home Setup Podcast. Thanks for listening. New episodes come out every Monday, Wednesday, and Friday, so there's always something new to dig into. If you got something useful out of this, I'd really appreciate it if you'd leave a 5-star rating and a quick review. It genuinely helps other people who are searching for this kind of info actually find the show. And if you haven't subscribed or followed yet, go ahead and do that so you get notified the second a new episode drops. See you next time.